With the applicable device group open on the map, open the Provisioning Wizard. The Provisioning Wizard opens. The first page populates with the carrier Ethernet service types, by default. In the Technology drop-down list, select Optical. The page updates to display the optical service types. In the service type list, select the circuit that you are provisioning. In this case, you accept the default selection of OCH-NC. In the Select Profile drop-down list, accept the default selection, which is blank. Note that, when provisioning tasks include common sets of configurations that users provision on a regular basis, they can define those parameters in profiles to automate and expedite complex provisioning tasks. Then, users can apply a profile based on the circuit that they need to provision. In automated provisioning, you do not select a profile. To continue, click Next. The Customer section page opens. Beginning on the Customer section page, the wizard provides a Cancel button. Important note, use caution when canceling the provisioning process. When you cancel, the wizard automatically returns to the initial page with its default settings and discards any information that you have added. The system does not prompt or alert you that it will not retain your changes. In the Customer Name drop-down list, select the name of the customer who will use the service. In the Details section, type a name for the circuit. Important note, when you type the circuit name, which is a required field, the Preview and Create Now buttons become available. To provision the circuit successfully, you need to continue the process because you have not yet configured the devices and interfaces that will support the circuit. In the Description field, type additional information about the circuit, based on operational or business requirements. To continue, click Next. The Circuit section page opens. On the Circuit section page, accept all of the system default settings. Note that, in complex provisioning scenarios, optical provisioners can configure circuit, route, and port properties on this page. For more information, refer to the job aid. To continue, click Next. The Endpoints section page opens, and the Alpha, or A, endpoint row is selected. To select the A endpoint, on the map, click the device with the port that you need to configure. The system applies the A icon to the device icon, and, in the A endpoint row, the device name populates the device name field. To select the A endpoint device ports to use for communication, click the A endpoint row. The row becomes available for editing, and the system populates the termination point drop-down list with all of the device's ports that are available for provisioning. On the A endpoint device, you need to configure the communication direction between the A and Z endpoints. To begin, in the termination point drop-down list, select the device receiving, or RX, port. The RX port is the port that introduces the signal into the system and transmits data to the termination endpoint, or TX, port on the Z endpoint. In the local drop-down list, select the device transmitting, or TX, port. The TX port is the port to which the Z endpoint local drop, or RX, port transmits data. To continue, click Save. To select the Z endpoint, click the Z row option button. On the map, click the icon of the device with the port that you need to configure. The system applies the Z icon to the device icon, and, in the Z endpoint row, the device name populates the device name field. To select the Z device ports to use for communication, click the Z endpoint row. In the termination point drop-down list, select the device transmitting, or TX, port. The TX port indicates the port that receives the data from the termination endpoint, or RX, port on the A endpoint. In the local drop-down list, select the device receiving, or RX, port. The RX port introduces the signal into the system and transmits data to the local drop, or TX, port on the A endpoint. To continue, click Save. With the device ports configured, you are ready to deploy the TIA1 output to the devices. As a best practice, Cisco recommends that you preview the TIA1 output that the system will send to the devices before deploying it, which helps ensure that provisioning will occur as expected. To evaluate the TIA1 output, click Preview. The Service Summary Preview Config page opens. The device field indicates the A endpoint, and the commands field displays the TIA1 output that the system will send to the A endpoint device. When you validate that the TIA1 output is accurate, you can deploy it to the devices. To start the auto-provisioning process, click Deploy. The system starts the provisioning action. When the system has deployed the TIA1 output, a system message opens in the wizard, indicating the deployment results. To continue, click Close. The system returns to the provisioning wizard, default, Start page. To continue, click Close. The provisioning wizard closes. In the circuit VCs list, the system lists the circuit with a gray, missing icon, which indicates that the system has not yet added or discovered the circuit. As auto-provisioning progresses, the icon transitions to the partially discovered icon. When circuits are online, and EPN Manager has discovered them, the system indicates the status with a green arrow icon. When circuits are up and indicating alarms, the system displays an indicator for the highest severity alarm that at least one of the devices is reporting. This feature can prompt you to take action, as needed, to clear any issues that might affect the service that you provisioned. In this case, the OCHNC circuit is up, and at least one device is reporting a critical alarm. You can use several methods to validate and evaluate a circuit, which we introduce in this demonstration. Future demonstrations and related job aids will address evaluating and resolving alarm situations. To review circuit details, click the Information button beside the circuit. The Circuit VC 360-degree view pop-up window opens. It reports the circuit's status, statistics, and current alarms when alarms are occurring. It presents key relationships and details about the circuit endpoints. You can open other circuit views or test the circuit. Note: when reviewing the information in the pop-up window, keep in mind that the system begins reporting statistical data and alarms based on the system monitoring policies and reporting parameters that administrators or users configure. Monitoring policies define such parameters as device polling frequency, the types of data to report, and reporting thresholds. This means that you might not see statistics, alarms, or other data immediately after device provisioning. To see the circuit's working route, click the entry row. The system displays the circuit overlay on the map and indicates the working route between the A and Z endpoints. During auto-provisioning, the system configures the circuit to support bidirectional traffic by default. When you apply the overlay, the system opens links to additional views and circuit details. To review network activity that affects the circuit, click Circuit History. The circuit history opens on the right side of the map and lists the types of network activity that have occurred. To see more details, click the Related Information button. To see a detailed view of the optical technology layers that are supporting the circuit's route, click Multi-Trace. The Multi-Trace page opens. The trace illustrates the circuit connectivity from the A endpoint device to the Z endpoint device, through the applicable intermediate points on the optical technology layers. The trace is available in a three-dimensional view or linear view. To manage the circuit components at an interface level, click an Interface button. The Interface 360 View pop-up window opens with interface details and provides access to actions that you can take on the interface. You successfully fulfilled a service request by provisioning an optical channel network connection